Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So welcome to today's podcast and another really interesting and exciting episode, something that's incredibly topical at the moment because it seems to be touching just about every aspect of our lives. We've been discussing it for a while. I wrote a piece about this over a year ago, but very much in the public eye. And I managed to get a real veteran of the industry who's got a lot of insight and knowledge about the space to come and talk to me about this. So if I could welcome Alastair Boyd to the show, who is a real veteran of the semiconductor industry. And we're going to talk today about all the supply chain issues, what's happening. Is it going to change? Is it going to get better? Is it going to get worse? And what's coming? But if we could just start, Alastair, by you explaining a bit about your background and where you're from and how you got into semiconductor space.
Okay, well, hello everyone. As Ryan says, I'm Alastair Boyd. It's actually 40 years this year since I left university. I did a degree in electronic and electrical engineering at Glasgow University. I'm originally Scottish. And I was always interested in electronics. But it was also a toss-up between computer science. And I swithered as to which way to go. Do I go down the electronics route or go down the computer science route? And in the end, I decided to go down the electronics route. So when I left university, I got a job as a design development engineer with what was Ferranti Defence Systems in Edinburgh. And I ended up designing or working on ring laser gyro inertial navigation systems for several years.
Wow.
So I was, I worked on fire control computers for Singapore Skyhawks. I did flight trials. And when I was working on the fire control computer, I was a senior engineer and I had to lecture. So I had a bunch of Singaporean engineers from the Air Force over, maybe about, I think, 15, 20 of them. And I had to lecture on the architecture of the box that I was a senior engineer on. And that's what gave me this little commercial spark, if you like. I had to write my own lecture notes, present it, and I thought, maybe there's more to life than being stuck on a bench. So age 28, I used to have all these technical sales guys come to see me, and I thought, I could do their job. And sure enough, a vacancy came up at a semiconductor company called Burr Brown. And I went for an interview. I was the first guy they ever hired from a non-sales background, from a pure design background. And HR said, no, he's too old. He's 28. We don't want him.
Oh, yeah.
But the sales manager did. So yeah. I went into Burr Brown and I did well. I was a naturally talkative engineer. Which is quite an unusual thing to get. Engineers that like
especially
talking,
electronics
right?
engineers.
Yeah. So, but I think coming from a systems background, where I was used to thinking as systems.
Yeah.
That's what stood me in good stead, and I had a strong technical background. So I did that really well. Well, I did that well. I enjoyed it. I learned my craft in technical sales. And after 6 years, I got headhunted. I went to join a semiconductor company called Maxim. Probably heard of them. I did well there. Jack Gifford himself, the founder, promoted me. My first big promotion. I relocated to England. So this is my expat life, if you like. And I've been down here for 26 years. So I did well at Maxim. Was there 8 years. I ended up as a director running Northern Europe. And one day I thought, I'm going to change. So I went to Linear Tech. Linear Tech, lovely company. I was there 15 and a half years, ran all the cold countries. I also ran Israel. They figured being Scottish, I was more aggressive than English guys, so they would
It's the accent.
let's give Israel to Alastair. He's Scottish, right?
Okay, yeah.
So I set up the legal entity and hired the first people in Israel,
Wow.
which was an interesting experience. And then one day we got the phone call that Analog Devices was buying Linear Tech.
Wow. Yeah.
So I was at ADI for three and a bit years, and then age 59, 60, I've now set up my own business, which I've been doing 2 years. So now I teach LinkedIn to technology companies on how to use LinkedIn properly. So that's what I do.
So basically helping new technology companies to do that sort of sales and marketing piece that you sort of specialized in early on.
Well, I'm at the stage now where I like teaching.
Okay.
And if I can help younger people come along and pass on some experience, then that's fine. I enjoy that.
Cool.
So basically that's me in a nutshell.
And a reference point on that, so Linear Tech are kind of a little bit famous, if you like, in the electric vehicle space or the battery system space, because they were really early with that dedicated battery management IC that's pretty much the standard in the industry today.
Yeah. Well, that was actually quite an enjoyable aspect, and that's also where I use some of my LinkedIn skills, because I focused on automotive in LinkedIn, and Linear Tech was one of the early first generation companies to do with the LTC 6802, 6800, 6801, 6802 battery management chip for lithium-ion cells. And it's actually quite interesting because it was Linear Tech at the time had a huge market share in the emerging EV cars, especially those in China.
Yeah.
And it was only by learning about real life problems with noise immunity and data transfer in a horrible environment that you then moved on to maybe third generation products, which are very robust. And it's that technology that forms the basis for what is ADI's wireless BMS chipsets. So yeah, it was very, very interesting to talk to some of the emerging smaller companies who were coming up in that space.
I remember way back doing trials and testing on those LTC parts in battery packs and having lots of issues with sort of noise problems and resistance to transients and things like that, which very excellent process working with Linear to get all of those sort of bugs ironed out, and a really robust product in the market, which is fantastic. So the topic of today's discussion kind of came about, actually, your LinkedIn stuff was being effective, and I saw you talking about this. I was about to do a podcast about this. This is a little bit different to the normal format, but I asked you as an expert who actually knew what they were talking about rather than me, who was sort of making it up as I was going along, if you would come and talk about the problems in the semiconductor industry, because it doesn't feel like you can go very far these days without sort of seeing and feeling the impacts of all these supply chain problems that we've got today, which are really get hampering so many sectors and fields, and actually it's quite hard to sort of really work out or get to the bottom of what's causing it, and I expect we'll talk about that. It's not a simple answer, I don't think, but really a lot of people are asking me, what's going to happen, what does this look like in the future, because at the moment it's almost impossible as an electronics engineer to design a new product because you don't know if you're going to be able to get hold of the parts.
That's true.
So very, very difficult. So I wonder, if you could just kind of start us off with your take on where the industry's at, and why do you think that we've got this sort of absolute crisis in the semiconductor world?
Yeah, you're right. It is complicated. Okay, you could say that it's actually a combination of a perfect storm with different events factoring in. So from what I've read, going into sort of the entrance to COVID, COVID time period did have a it did have effects. Now, the effects that happened were specifically relating to the automotive industry. Was with COVID lockdowns and shutdowns globally, the automotive manufacturers forecasted a downturn in the number of cars and vehicles they would need to make.
Yep.
So they cancelled their backlogs on their whatever semiconductor supply chains they had. They cancelled backlogs and they burned off inventory. Now, going into COVID lockdowns, what then happened was people they were locked down. They started to work from home. So guess what? That meant the consumer products just went up exponentially. So things like setting up people to work from home, laptops, phones, and also children's gaming machines, right?
Yeah.
They just took off. So they took up. So bear in mind that the semiconductor manufacturers themselves were also suffering from COVID issues, primarily to do with workforce. And especially with that downturn as well from the automotive industry. And they were struggling to get their act together to maintain the same level of output. So when you actually look at what happened then, so automotive companies are used to just-in-time operation in their supply chain. Now, that's great when things are normal, but when things are not normal, then you've got a problem. So you throw that in, this big surge in consumer-type products and computer-type products take up a lot of semiconductor capacity. Then at the same time, you've got delays in the whole way through the manufacturing chain for semiconductors. So the raw silicon wafers, be it 200 millimeter wafers or leading edge 300 millimeter wafers. Then you've got bottlenecks in assembly, where you actually take the bare die and package it. So they've got different countries with different issues, and maybe Malaysia for packaging, and then you've got the test issues as well. So there's bottlenecks every way along the chain, and it just takes one issue to be very, very difficult. And then you throw in some strange ones like fires in Texas, or bad weather in Texas, or brownouts, right? And then Renaissance had issues in Japan. So you throw all these little factors in, and it just causes this massive headache to actually get stuff made. So I think the industry, what's happened, it's to sum up, it's really just a mismatch between demand versus supply. Yeah. That's it in a very simplistic term. But the semiconductor industry is ramping up, is growing fast. And I think what it has shown within the automotive industry is that the automotive manufacturers need to rethink their supply chains. So, and again, I've looked at some of the, and I've always been slightly confused about automotive guys. They have confused me over the years because I'm never sure what they are.
Sorry.
Right? In my mind, either they're just big system integrators, right? Where they take black boxes from their tier ones and tier twos, or are they technology companies? Now, so you look at what's happened with the real technology companies like Apple, okay, when and Dell. These guys, when there's a shortage coming, they know how to act. And I think that's what's happened, is that apart from maybe Tesla and Toyota, who are beginning to act like technology companies in terms of getting their own silicon made. Yep. But the rest of the guys are acting like system integrators. So they're going to have to figure out what it is they want to be and how they get better relationships with, at a high level with the semiconductor suppliers.
Yes, it's an interesting problem in automotive, particularly. One of the other issues that often gets raised with me is that effectively the automotive industry is very tough on its supply chain and has driven down margins over years, and therefore actually profitability is not great in the automotive sector. So there's good volume there, but not necessarily profitable volume, and that's sort of caused a reluctance on behalf of some of the semiconductor companies to make investments in the space. Also sort of coupled with a lot of the components, like in automotive, we've got this quite sort of unique issue where when a component is designed in, it's validated, extensive testing's done, that part's designed in, it's really difficult to change that then, because you've got a whole other set of testing costs. So kind of moving around and changing the supplier of a component, even if it's a like for like component, is actually quite difficult within the automotive space. So they don't have the flexibility to change suppliers once production's up and running, but they've typically, been quite tough on that supply chain. You've been on the sort of semiconductor industry side of that in your career, I would imagine, a number of times. Do you think there's anything in that?
I understand the limitations in automotive, right? Now, in terms of dealing, it goes back to the question: who's the customer, right? And again, this is part of the confusion about the automotive. Who is the customer? Because the automotive guy may not buy anything. Okay, he's not the one placing purchase orders on the semiconductor manufacturer. That could be a tier one guy like Bosch or Continental. Tier two, it could be a Valeo, it could be a Visteon. They're the guys who actually place the POs on the semiconductor company.
Yeah.
So the question is, who's the company now? The automotive guys might have all these liabilities about, if you don't deliver X quantity on a particular date, you get all these penalty charges. But it's one of these things that is. And at the same time, if you've actually been screwed down to be a low margin business, do you really want to be in that business? So if you've got a capacity to make a particular number of a specific component, and you can sell that stuff at a much higher price, higher margin to an industrial guy who isn't going to hit you with all these consequential damages, who do you want to do business with? Right. So I think. Now, at the same time, right, we all know that the semiconductor content of cars is going up hugely, right?
Yep.
Now, the question is then, is that old model of pushing your supplier down into low margin business with lots of horrible terms and conditions, is that going to work if your semiconductor content goes up by a factor of 10?
Yeah, you need to be forming stronger partnerships with these companies. One other thing, actually, that was a sort of an interesting little nuance on it was that, because of this sort of design cycle and components getting designed in, a lot of the parts that are used in automotive. So you've got, broadly speaking, we've got kind of microcontroller type devices, and we've got power type devices. And in the microcontroller or the processor industry, we've effectively, year on year, like, new capacity is created through the design of better devices, basically, where you get more devices per wafer. But a lot of the devices used in automotive are actually fairly simple, and you're locked in quite often to a 5, 6, 7-year-old, if not longer, device. So you're not necessarily taking advantage of the latest processor technology, but then also that design is typically going to be on an older. You mentioned earlier 200 mil and 300 mil wafers, which has been another change in the industry to increase capacity, increasing the diameter of the wafer so you can get more components on a wafer. But again, a lot of the automotive parts are locked in on those older 200 mil wafers, and it's really difficult to change that manufacturing process to really create extra capacity without just installing more lines and more equipment, which is a difficult thing to do. Again, based on your experience in the industry, is that something that you recognize, where maybe the new capacity is going into the sort of sexier micros and the sort of nanometer feature sizes and all this kind of thing?
Well, the industry is in two halves, right? And it's as you said, you can have functions that need small geometries. Okay, they'll be then this 14, 10 nanometer area, or on a 300 mil wafer, right? But then the automotive on the power side is moving to new technologies, so silicon carbide or gallium nitride. Now they're different. They're what's called more than Moore. Now Moore's law talks about the number of transistors doubling on a wafer every year, and that's where the small node geometry products are coming in. They're the ones built by TSMC or Samsung, and that's great for real volume business. But automotive is fundamentally a high mix, low to medium volume business, and your products need to last for decades, for many, many years. So it doesn't actually matter that you're not on the latest small geometry type product. I think it's probably only when you get some new features like when you move to autonomous vehicles and you need the latest LiDAR technology, that or the real leading edge stuff. But for analog type components or mixed signal type components, you don't need to be pursuing that race down the rabbit hole of small nodes, if you like, and you can't compete. Even the biggest automotive guy in the world can't compete when an Apple comes along and says, "I want X gazillion number of products based on this process," right? Because Apple's taken up most of TSMC's fab capacity for their products, right?
Yeah.
So it's actually okay for the automotive guys to be on older processes. They don't need to be on it for their functionality and for their longevity of their products. They just need to get better at their supply chain.
Do you think though those older parts though create an issue in terms of new capacity?
I don't think so. I don't think they are, because there is a lot more demand for the 200 millimeter wafers. Okay, so that might put a lead time issue on the 200, because a lot of the industrial guys also want these high volume, these high mix, low volume type products on the smaller, on bigger geometries, but they've got extra bells and whistles, and that's what they mean by more than more. You're getting different types of packaging. You're getting different types of thermal performance. Obviously the foundries need to have more capacity on these 200 millimeter wafers, but in terms of the fact that these products are going to have to be supported for a long time for the life of that car, that's, in some respects, you don't really want to go down to the huge volume Moore type path. It's not suitable for automotive.
Okay, yeah. And the power devices are interesting in themselves because there's not all that much from a technology point of view. You know, if you've got a silicon carbide device, there are some things, trench devices and things that can be done to get more devices per wafer, but fundamentally the amount of devices that you can get on a wafer for a given amount of current or power switching capability is quite fixed. So if you've got a big increase in demand, which is coming for power switching devices from all sorts of sectors, from energy, from electric vehicles, robotics, et cetera, then creating new capacity really can only happen with new lines and new manufacturing plants.
Yeah, and unfortunately, that's what takes time. That's why when you've turned something off, turning it back on again is difficult. It takes a long time to get new. I mean, if you look at what people at TSMC are doing in terms of setting up in America or setting up in Singapore, it takes time to do that. You can't just suddenly turn it on. So I think, you asked originally where will things get to? And I think the semiconductor industry, things will get much better, but I think at the same time, the automotive companies need to get a much better handle on the silicon that's going into their cars. Yeah. So, for example, again, it goes back to this. It's almost like a three-way relationship between the automotive OEM, their tier one, tier two suppliers, and then the semiconductor OEMs. It needs to be a three-way alignment so that BMW or Audi or Tesla, they know exactly how many Intel parts, how many NXP parts, how many ST micro parts or Infineon parts going into their particular brand of car. Yeah. And the question is, of those parts that are going into a car, do they know the ones that are strategic, the ones that they desperately cannot do without, and are they then working with the semiconductor manufacturer to put in accurate forecasts to say, hey, look, this is the demand for BMW, this is the demand for Audi. That's what they need to get better at. The onus isn't just on, the semiconductor guys will ramp up as much as they can for their global demand in all applications. But automotive guys, I think, just need to improve how they engage in their supply chain.
Yeah.
And I think there was a great article came out of Harvard Business Review that said that CEOs only spend 1% of their time with suppliers. And this goes back to, this is where the Teslas are winning. They're having high level engagements with the semiconductor suppliers.
Yeah.
And that's what the other guys, the Fords of the world, that's what they need to do as well. Have that relationship with semi guys.
And I think that's particularly important if you are more of a system integrator than a technology developer. You know, if you kind of control the vertical stack, you know, maybe actually what you do inside is more important than outside. But if you're very reliant on that supply chain for your technology, then you know you do need a high level of engagement. It was interesting. You mentioned earlier the Tesla and Toyota, and you've got some of the tier ones who've kind of dabbled a little bit, but Tesla obviously sort of, it's well known that they've got into the design of their own high power processing modules. And Toyota, quite interesting, because actually for years now, I think, I don't even know how many years, but they've actually designed their own switching devices, because they had a unique operating voltage level in the Prius powertrain, I think even from first generation Prius. So they've got a certain amount of expertise in the design of, they do some of the packaging, I think, in-house. I'm not sure if they actually do the fundamental foundry stuff in-house. But on there, people like Bosch, who've, you know, obviously Bosch are into everything, but Bosch have some in-house development and manufacturing for semiconductor parts, but an awful lot of bought in pieces as well. Do you have a view on that in terms of what the right or wrong approach is in that space?
Well, again, it goes back to what they want to be, right? So I think I won't say it's schizophrenic, but the fact is that are the automotive companies, do they see a strategy to become a technology company? Right now, Tesla is a very interesting company. I can't say I know huge amounts about it, but all I know is that when you start designing your own silicon or working with third parties to get your own unique silicon designed for your product, they tend to move quite fast. But then Tesla's got his hands is areas and a whole lot of other areas like energy. So it's funny. I probably disagree with some people in the past, but I've always pegged Tesla as an energy company, right? And they're competing with oil and gas industry now. So rather than just a purebred automotive company, because I think it's all about moving energy around, and they're into solar panels, they're into second life batteries, Tesla's Powerwalls and stuff. So yeah, they're a very diverse company who think about technology. So the question is, for the other guys, do they think about technology in the same way, or do they want to become just better system integrators?
Yeah.
Right. And you can do both paths, right? You can. But if you decide to stay in the picture just being a systems integrator, but get good at it, then as long as you're building those three-way relationships to include the key semiconductor suppliers for products that go into their cars, then that can't hurt. That's only got to benefit them all. It'll also benefit the semiconductor guys, right? Because the last thing you want is some big guy shouting at you and banging the table and demanding product. And that's what happens when shortages happen. It shouldn't be he who shouts loudest gets the product. It's like he or she who works with us carefully and tells us what their demand is, and allows the semiconductor companies to plan for it. They're the ones who will get the benefit.
Yeah, it's interesting because it almost the whole sort of manufacturing process methodology in the semiconductor world, it doesn't align itself to a kind of one piece workflow lean manufacturing model that the automotive guys have got at the vehicle level. So you by nature in semiconductors you have to process batches at one time. You're making sometimes thousands of components on a single wafer, but you'll be processing multiple numbers of wafers, I think 24, 25 wafers or even more at a go, through a process, which actually takes a really long time. Like these manufacturing to process a wafer from bare wafer to finished component, it's not a kind of 2-day job. It's weeks and weeks and weeks to push that all the way through. So you've got a lot of material tied up and components tied up in inventory and a fairly long cycle time to go through a plant, which if you're not holding inventory and stocks, then creates a big problem when you're ramping up again.
Yeah. Well, I mean, the other question I think people should be asking of their semiconductor suppliers is, where's the product made and how's it made, right? Because many semiconductor companies have their own wafer fabs, and they might have a strategy whereby they build some products internally in vertical integration, or some they go outside to outside fabs. Okay, so knowing now, if you can do something internally, if you happen to have your own wafer fab, you might even do your own assembly, you might even do your own packaging, your own test, you can prioritize.
Yeah.
But if you go to an outside fab like TSMC or USMC, it's much harder to get them to change their schedules to accommodate you. Okay,
Yeah.
so if you can understand that you've got, say, 10 absolutely, products that are strategic to your manufacturing operation, if you understand how they're made and where they're made, then you can have a different conversation.
And
So,
well, and to a certain extent, that kind of fabless model is what they call it. Has been very popular over the last few years, particularly with investors in newer businesses coming up through the semiconductor. Because obviously, building a fab is a really capital intensive task. You've got to have a certain amount of volume going through it for it to be profitable. And a lot of companies have gone down that fabless model historically, but yeah, you do wonder how sustainable that is in the long term, because you kind of I got a bit of experience in semiconductor space recently, and understanding how the process actually in the design are so interlinked on these sort of higher tech products, if you like. So the manufacturing process is not a simple commodity that you can just farm off to Joe and he's going to do it, and you get your parts back. The manufacturing process actually and the process capability really drive what you can do from a design point of view with the devices. So there's a very, very close linkage there. And the development of better devices is often completely dependent on the development of a better process or the improvement of some sort of process technology element. So do you think that the fabless model, is the best model for the future, or do you think we'll see companies start to move away from that?
I don't think they'll move away, because I think there are some applications and some functions that it's only by having the really leading edge fabs that TSMC or Samsung might have that can make these products. So I think the answer to your question is, it depends on the application, right?
Yeah.
No, it really does, right? Because you cannot have one size fit all. Now, the whole thing about going fabless, and these guys are really good at what they do. You just have to hope that no geopolitical events come in that could affect that supply chain, and that's why risk management is now a big important part of supply chain, and that's why Europe, the EU, is getting much more. They want a larger share of manufacturing in Europe, and America does as well, because America, I think I read somewhere it was like 1990, it was almost like high 30s, just under 40% of their products were made in America, fabs in America, and now I think it's like 12%.
Yeah.
So they've pushed fabrication offshore. So again, going back to risk management, they're trying to bring it onshore just to reduce the length of supply chains. So I think what you'll find is things will eventually settle down. We're in a particularly turbulent period over the last couple of years, but then again, you always get cycles in the semiconductor industry anyway.
Yeah.
It's just been excessively bad this last couple of years. But I do think automotive guy. Now, take a step back. Everyone knows that the semiconductor content of cars, of automobiles, is increasing significantly. Right. So that means that you have the attention of the major semiconductor players. Right. So they're staffed up. They have more and more sales and marketing people engaged in automotive, as in trying to build relationships with the OEMs, servicing the tier ones and tier twos, and also looking at some of the emerging technologies. Right. So if you read the annual report of all the big semiconductor guys, automotive comes through time and time again. So you've got their attention. Okay. What you can do is work with them at higher level, to say, look, how do we partner together? How do we share technology together? How do we talk to each other about our business together, right?
Yep.
That's what needs to improve. Even if you don't want to become a fully fledged technology company, but you want to just put all your boxes together as a systems integrator, you can still have those conversations, because I think they'd be pushing on an open door, quite frankly. It's in both parties' interests to develop better relationships.
Yeah. One thing that strikes me as maybe a driver for where some of the issues have risen, and you just mentioned it actually, that in the past, a lot of the manufacturing has moved for semiconductors to Asia. So the two sort of big names you mentioned, Samsung and TSMC, are vast. Obviously, there are a couple of players in the US and in that sort of contract fab business. And some US chip makers with their own in-house manufacturing as well, and but predominantly, semiconductor production is in Asia. I guess it's always struck me as a bit strange, really, that happened in the first place, given that as an industry, it's pretty much there's very limited amount of labor going into actually making wafers. It's a very highly automated process. But why do you think that happened? Why did the manufacturing go that way? And how do we get it back?
Well, again, good question, but I don't know the history of TSMC. I've not read it. Okay, all I can think of is that it's expertise and knowledge, right? They have found their niche, and it's just got bigger and bigger and bigger. And it just so happened that the functionality and the performance they were offering the market was very attractive to many of the big semiconductor guys. So, I've got lots of books on semiconductor history and so on, and one from my last employer, Analog Devices. They developed, public domain information. They developed a very early relationship with TSMC, and they talk about it in their book on history of ADI. So TSMC obviously had something to bring to the party, and I think it was obviously what they could offer in their fab processes. People in some of the smaller guys, so you would find that you might have a like what used to be Jazz Semiconductor or Tower. They would offer like a silicon germanium process, and people would go to them for very, very high speed RF type semiconductors. So again, it goes back to, and I am slightly confused about. I need to read more about it, about what the EU is trying to do, because I think the amount of semiconductor manufacturing in Europe is quite low in compared to America and certainly Asia.
Yeah.
So it's a bit like, well, apart from throwing money at stuff, what do you want to actually do? Right? Yeah. And then there's been a lot of dialogue about the UK in semiconductors, and I was going, well, again, what do you want to do? Because that boat for the UK, that boat sailed decades ago. So my gut feel on these companies are these challenges is you need to pick your niche of what you want to be good at. So it could be that there's going to be a lot more performance areas in what I call more than more. Okay, where you're adding all this extra functionality and bells and whistles onto the functions available. And some of that stuff is going to use high-speed interconnect using photonics. It's going to be SIP packages, SOT packages. So I think if the UK, for example, were to find a niche and dominate that niche and get world class in it, then people will come to them for that type of functionality.
Yeah.
So you cannot be all things to all people and expect to win on a global stage. You're going to have to find your niche.
So do you think it's practical? Could we expect to see more semiconductor manufacturing capacity in the UK, or do you think there would only be?
We don't really have the fabs we used to have, and then there's all this hoo-ha about whether certain parties, some countries are going to buy the fabs we do have over here. So yeah. I don't know. I mean, starting from scratch is difficult. You certainly can't compete financially with the sort of the Moore type fabs. Like TSMC, it's just too expensive, right? So you need to pick a niche of what you want to do. We're not going to go down the Moore route in the UK. Just can't afford it.
Yeah.
So we have to find some other route to go.
And that's the current sort of direction appears to be around compound semiconductor devices
Yeah.
For the UK.
Yeah.
So some
Wide
investments,
bandgap stuff.
yeah, in Scotland in silicon carbide, in manufacturing for that, and various other things going on around the country, which power devices. So obviously key components in drive lines, but not really looking at processing technology. I think we've got a bit of a photonics industry in the UK as well, and some big projects happening on that side. The EU strategies, it's an interesting one as well. So that's basically where my understanding of that, they said, right, it's such a underpinning sort of cornerstone of all of our industries. If we don't invest in semiconductor, we've got a problem. Historically, we had issues with governments in other countries supporting capital investment, much more than we did. So we're going to throw money at it, like you say, and the hope, I guess, the hope is that some of that sticks to the wall, and we end up with some really big increases in domestic manufacturing, or EU-based manufacturing for semiconductors. But it's a long game. I guess in your time in the industry, you've seen a lot of new fabs and facilities built by the companies that you've worked with. Can you, as a sort of idea, how long does it take from sort of planning to a new facility churning out parts that can actually be used?
Well, I think you have to assume you can get the staff, right? So if you can't get the staff, I mean, that's I read about, again, public domain information. It was an article about TSMC moving to Texas, and I think it's Intel out there. Even just hiring the right people with experience, when you're the new boy and you move into a territory that's got a big incumbent, it's not easy. It really isn't easy. So I think there have to be the people, they have to have the skills and the experience. So you either have to grow them organically, as you scale your business, or you have to bring them in from outside. And everyone's looking at I read somewhere that Tesla's looking for battery engineers with six-figure salaries type thing. So if you've got to get the people. First of all, you've got to figure out what you want to do, right? And if you get that wrong, it's a waste of energy. But if you get it right, and then you try and build your business and scale your business and stick to, one of the reasons why, guys like companies like Maxim and in the days of Jack Gifford and Linear Tech and with Bob Swanson, the reason they were so successful from going from tens of millions of dollars to $1.5 billion was they had a strategy and they stuck to it. And they were consistent, and that's why they were successful.
Right.
So saying both companies got bought, but they were successful up to that point, right?
Maybe that was their idea of success, actually being acquired at some point.
Oh, no. Successful as in they were both highly profitable companies, right? Very profitable, and they had their niche. But even people look back on Linear Tech with fondness because great technology, and what people forget about is the average lead time for a Linear Tech product was 4 weeks.
Yeah.
Okay, the ability to hit that was over 95%. So that's because the whole company was vertically integrated, did its own fabs, its own assembly, its own test.
Yeah. They must have held quite a bit of inventory as well, though.
Well, it depends on how you define inventory, right? So it goes back to what is the cost of a wafer compared to having wafers in inventory, or do you have finished goods in inventory?
Yeah.
Right. From an accounting point of view, it's much cheaper to have a wafer.
Yep.
And the other thing that people are not aware of is that when you start a wafer, you might get if people have a delay in their product and their lead time, it could be to do with yield. You might not get the yield you expected. So when you run your own fab and you start wafers, you can have what's called a phantom wafer lot, 2 weeks behind. So that it's the same wafer, but it's just 2 weeks delayed. So that if your first batch doesn't give you the yield you need, you've got more wafers. You don't have to wait for the full fab processing time.
Yeah, so that the yield issue is quite an interesting one where, again, I think a lot of people just assume it's like a sort of printing press where and a full wafer of parts comes out. But actually, like I mentioned earlier, that the manufacturing process is so complex for these things. It doesn't take much to give you a problem. You might have a particular region on a wafer where the components aren't viable, don't work properly. So we talk about yield and dropout, and sometimes that yield can be quite high, sort of 20%, 30% fallout rate. So, an 80% yield or 90% yield. So 90, anything north of 90 would be considered good. So you always expect some devices to not be viable. But it is an issue in the industry, which is, I guess, if you're vertical, you can do more to control that. Whereas if you are fabless and you're in the supply chain, actually, it'd be really, really hard to do that because the fab is just working to your order.
Yeah. I mean, it would take you long enough to even find out who to call to try and pull forward something, So it's yeah, it's tough. But all you can do is build better relationships. And what I always used to try and teach my customers was, you get one silver bullet. Okay. Now we had a case. I won't mention names, but we had a case where I got a phone call, and it was a silver bullet phone call. We'd had a big CM call, like a vice president call, because their delivery truck with I think they had something like 47,000 of our components on it, got hijacked. Okay.
All right.
Got nicked. Right?
Oh no.
And it was like, and they had their big customer, who was actually my end OEM. And if we'd had to wait 12 weeks for delivery of product, we would have killed my end OEM's end of quarter and end of financial results. We'd have killed them dead, okay, because they couldn't make what they were making with our chip. And this silver bullet I took to my VP in America, and they basically prioritized everything to the point of hand carrying all the material to the next stage of manufacture. And we had, I think we had those 47,000 devices replaced within 2 weeks.
Yeah.
And the OEM, we never even told the OEM what we'd done.
And I guess, again, as a vertical business and with good relationships and shorter supply chains, because that's a bit extreme, and there aren't that many, although given the way the market's gone at the minute, it wouldn't surprise me if suddenly it did start to see trucks getting hijacked. But actually, with a global supply chain, it really doesn't take much for a container to get lost or fall off a ship, or a ship to get stuck, or problems at a port. So these very, very long global supply chains are. I do feel like people have maybe forgotten some of the risk elements. Very focused on the cost today without really taking into account properly all of the risk costs of operating a very, very long supply chain.
No. It goes back to what you were saying about automotive, maybe pushing suppliers down the margin. There's a fundamental difference between price and cost. Okay, and you understand price well, but they don't understand cost. That if you cannot get out that one chip, and you cannot build a car because of if you cannot build a $30,000 car for the sake of a $5 chip, what's the cost of that? Yeah,
and I think we're seeing a lot of that. Actually, the CEO of VW Group talking about that at some length, that he couldn't ship cars because of, it wasn't even $5 components, it was like 80 cents or something, but big problem in the industry. So in kind of a summary, if you were obviously loud and clear through this discussion about building better relationships with the supply chain, but if you were designing today, if you were working on the other side of the fence as a developer of electronic systems, so a user of parts, processors and power devices, and et cetera, what would you recommend to people? Like, what would you do if you need to launch a new product or you're working on a new design? How would you deal with the problems that exist in the supply chain?
I think if you're at the coalface and you're a designer and you're faced with designing a printed circuit board for whatever function, right? You need to have the relationship locally with the manufacturer, semiconductor manufacturer. You need to understand more about the chip. You need to understand, is it a mature chip? Is it in mass production? Does it have hundreds of customers, right? Or does it have 2 customers globally who each take X million, right? You need to know what you're designing, and you need to know is it fabbed? So you need to know a lot more about it. Is it fabbed under the semiconductor its own fabs?
Yep.
Does it go to an outside fab model? What about assembly? What about test? Just know more about it, right? How long is it going to last for, right? Because the last thing, I mean, I've seen companies designing products which were primarily targeted for consumer applications that lasted a year, right? So the chances are the manufacturer may obsolete the part within 2 years, and you've got a product that's got to last 20 years.
Yeah.
Right.
Yeah.
So, the last thing you want is to have to tell your boss you're going to have to redesign the product due to obsolescence issues because you chose a part that's not suitable for a long life application.
Yeah.
And then the other thing about it is, and we haven't even touched on it, is this always all the AEC-Q qualifications for semiconductors, right? It takes a lot of qualification. It takes a lot of work for a semiconductor guy to do these qualifications for automotive. Now, I'm just going to throw out there the fact that cars are becoming, they called it servers on wheels, right?
Yeah.
If you've got all this new functionality for autonomous driving and LiDAR and everything else, are these chips going to be automotive qualified?
Yeah.
Are the other semiconductor manufacturers going to make them automotive qualified? Or are they going to be commercial chips used in cars? Because you might not be able to get them in automotive qualification.
What's your view on generic sort of components? So we've got, particularly for processors, obviously you've got very specific components, and different suppliers have got their own technology and etc. But then we've got, I don't know, so sort of something of a market starting to develop for generic parts, which are
things. I mean, you get microcontrollers, some like 8051s with multiple suppliers. As long as you've actually tested and really thrashed your design with 2 or 3 different supplier type products, and you're happy they all work, then that gives you an option. That does give you an option. But if you're talking about something really, really leading edge, then that's more difficult.
Right. Yeah. So the generic market is possible, but be aware that actually, even though they're the same, they're probably not exactly the same. So you do need to test with a couple of different ones to still have that flexibility.
Yeah, and same with the analog world. There's no such thing as a true second source now, unless you're using the same wafer fab, because the analog fabs, they all have their own little quirks and idiosyncrasies, shall we call it. I mean, your design might be optimum, so it might be, you might be safe enough that you can use two op amps from a different manufacturer. But if your design's marginal over temperature, you might find that one manufacturer's chip works better than another manufacturer's chip.
Yeah. I've actually personally been caught out by that in the past. This is years ago, before we even thought about semiconductor crisis, but had a supply issue with a particular part and we swapped it out. And it was a very innocuous, simple component. We swapped it out for something which should have been a like-for-like replacement, and it didn't work and causes all sorts of issues. So, just because they say they're the same doesn't necessarily mean they're the same. And I think that comes back, the circle back there is the manufacturing processes for all of these things are so complicated that if it's coming out of a different factory, there's going to be some variation from the part. So you need to be aware of what those variations are. So then looking forwards, so in terms of, being designers, kind of making sure that they get that engagement with suppliers, understand the parts properly, obsolescence plans. Some really good advice there. What's if you had a crystal ball and you were kind of looking forwards, where do you think we're going to be as an industry in 12 months' time, or maybe further forward? So what's going to happen in the next 12 months, the next 2 or 3 years?
12 months is a short time. It really is. I hope there'll be less stress on the whole supply chain in 12 months. I hope sourcing guys can sleep at night, manufacturing guys can sleep at night. Longer term, given the sheer rise of semiconductor content in cars and vehicles, I really hope the automotive executive management are sitting down together and saying, how can we make it easier? How can we make it seamless to have? What kind of relationship do we want to ensure we're not constantly firefighting?
Mm.
That's the because this thing's coming, right? If you, regardless of what aspect of a car you're talking about, be it electrification, be it vehicle to V to X, V to I type communication, in-car networking, all the lidar type, radar type stuff, all the sensor fusion in a car, number of sensors. It's inevitable. You can't stop it. So you're going to have to figure out how to deal with it.
Mm. And do you think the automotive world can? Yeah, I guess you've sort of already answered this question, but there's so many exciting other tech areas like robotics, for example, which we've not even scratched the surface of, in terms of applications for robots outside of industry, and in the wild massive announcement from Dyson in the last couple of weeks about what they're as much as Dyson ever tell you what they're planning to do.
They were looking at home robotics.
Yeah, home domestic stuff. So with all of these other things coming through on top of consumer electronics, etc., do you think that automotive still has a voice? Is it able to compete?
Yeah, I think automotive's going to get a bigger voice than it realizes. They just have to figure out how to channel that voice. Honestly, all the semi guys are focused on automotive. There's a tsunami of applications coming around, and it's not just hardware, right? I mean, it's all the software as well. And then there's all these services, right? All these 5G enabled services that are coming along. Yeah. So there's a huge ecosystem. And automotive is at the core of that ecosystem, along with communications, 5G, 6G. Yeah. Along with artificial intelligence, the metaverse. It's all coming together, and the platform is going to be the car. Yeah. So these automotive guys need to figure out what kind of conversations they should be having. Yeah. Right. And who they want to have them with.
That's very interesting. Because you mentioned about Tesla being an energy company, which they that's what they say they are. I always thought one of their strengths, and it's sort of almost a hidden strength, is in autonomy and machine learning. So I think they're very much ahead of the curve there. And some of the things that they've announced that they're going to be doing, like the Tesla robot, like actually people kind of go, what? Why are they doing that? But when you think about it, it's a battery system, it's motors and drives, and it's a big processor. It happens to be on legs rather than on wheels, but it's fundamentally the core skill sets that they've developed applied to a new application, potentially, and also probably helps them with quite a few problems they've got in terms of hiring people to do jobs in their own factories and plants and things, let alone selling it to other people. So, an interesting company doing things a little bit differently. Again, so. One last question, and then it's mindful of the time, so we do. But do you envisage more automotive companies going vertical, so taking ownership for design or even perhaps manufacturing? So, and really the only one who's in public sort of putting an investment in as a tier one is Bosch, in their own manufacturing capacity. Do you see others following and doing the same?
Well, I saw an interesting article last week about, I think it was Bosch buying other companies to allow Bosch to get more into autonomous driving. Right. So, again, it's fascinating. It really is, whether the whole relationship between the automotive OEM and the tier one. So the automotive OEM have hired hundreds of electronic engineers, right? And I always used to wonder, what do these guys actually do? Right? No, seriously, because do they just want to write better specifications that they can give their tier one suppliers? Yeah. Or do they want to do something themselves? And I think the answer is probably a bit of both. But they do want to do so. The question is then, within the car, what do the OEMs want to take ownership of? Yeah. Right? And that's what I was never clear of, as to what functionality they'll take ownership of. And then, because you jump back to the linear tech days on lithium-ion battery chargers, the automotive OEM couldn't say, to the tier one, use this linear tech lithium-ion battery BMS chipset.
Yep.
Because if it screwed up, if it failed in the field for whatever reason, the tier one would say, "Hey, you told us to use that.
Yeah,
it's your fault."
Yeah.
So again, it goes back to what bits of the car functionality do the OEMs want to take ownership of? What do they have the capability to take ownership of? And to offset that, the tier ones are trying to become more capable.
Yeah.
Right. So I don't know. Where it's fascinating where it's all going to end up. I don't know. I mean, are we going to see consolidation? Are we going to have an automotive OEM buying a big tier one?
I
don't know.
I mean, even that's an interest, because in some ways that sounds crazy, but actually, all the big tier one, well, not all of them, many of the large tier ones came out of OEMs in the first place. Like, they were part of an OEM and they were span out years ago because it was seen as a better business model to have the tier one supply outside and introduce competition between competing tier ones. But now, actually, you look at, Tesla or some of the other new OEMs, and they are doing a lot more in-house than a traditional OEM, which is interesting because they're a newer company, so they've had to develop those skills more quickly. And actually, in the case of Tesla, running very deep partnerships. So on the battery side, very, very deep partnership Tesla have had for a long time. But also on the semiconductor side, they've cooperated very, very deeply with their suppliers. And obviously some issues on the bigger processors, and they've gone their own way or going their own way on that. But on power devices and things, again, very deep supply chain relationships that they develop there. So it is an interesting one in terms of where the older or more traditional OEMs are going to end up landing and what that relationship looks like. There's certainly been, because whilst there hasn't been an OEM buying a tier one, to my knowledge, but there's been a heck of a lot of consolidation in the tier one world, and particularly driven by electrification and acquiring companies with more skills and expertise in electronics and software development. I mean, that's the biggie, whether that's around battery systems or power conversion, motors and drives, etc. But a huge amount of activity on that front. Someone's going to correct me on that, because maybe it has been an OEM. Trying to think, there probably has been an OEM acquiring a tier one, but there's been a lot of tier ones acquiring tier ones and big tier ones acquiring little tier ones, and I mean, that space in automotive has been absolutely alive. Interestingly, what we haven't seen yet is a tier one really acquiring, anything across like a semiconductor manufacturing business, which might seem a logical way forwards, but that doesn't seem to have happened yet.
I think it goes back to cost, right? Come on, do they have a spare 20 billion euros to go buy a semiconductor company? But just one other aspect about having automotive OEMs do some technology stuff themselves. There's one benefit of that, is they move faster. Okay, they can move much faster, so they can adapt and time to market quicker than having to deal with tier ones and tier twos and bolt it all together. So again, it goes back to, that's why I think Tesla got the lead in terms of getting to market first. You've got to stay ahead of your competition. You've got to be fast.
Yeah.
So there is that element to it as well.
Yeah, interesting. And that is a really good point to end it. So staying ahead of the competition, staying fast, keeping nimble. It's been fascinating, Alastair. Thanks so much for taking the time out.
Well, thank you very much for inviting me, Ryan. Talk to you soon.
Brilliant. Thank you.